Hi everybody, welcome to one of my first mathematics videos, Maths Made Easy. In this video I'm going to show you guys how to simplify algebraic expressions, both the addition and subtraction types. Moving on, how do we simplify algebraic expressions? Well, before we answer this question, let's define what simplify is. Simplify pretty much means that we have to reduce an expression down into its simplest form. For example, if I were to simplify 1 plus 1 plus 3 plus 1, I would do this. I'd go 1 and 1 is 2, plus 3 plus 1. 3 and 1 is 4. Simplifying that, I get 4 plus 2 is 6. So in respect of simplifying this expression, we reduce it down to a single variable, which is 6. And in the same way, we apply this this concept to algebra as well, except that when we deal with algebra, we deal with more than one type of expressions, more than one type of like term. In that case, we're only dealing with numerical like terms. But in the case of algebra, we're dealing with like terms which can vary, and not all of them can be simplified, and it gets more complicated. But looking into that, I'll show you guys 3 steps that will allow you to simplify any expression, addition and subtraction, no matter how big or how small. So moving on, we follow these 3 steps. First, we identify the like terms, and when I say identify, I mean we look at what's there. So, are there any x's? Are there any y's? Are there any numbers? Are there any x cubes, x to the squared, or x to the power of x? You name it, you have to look for it. So basically, we investigate the expressions and see what's there. Next, we group the expressions. So when I say group, we not expressions. We group the like terms. So when I say group, we mean that we group the x's, we group the y's, we group the z's, the x squareds, and numbers, so it becomes easier to simplify. Right? And an example of that would be x plus 3 plus 4 plus 5, or y plus 1 plus 2. So they're both separate groups. And then once we've grouped the like terms, then we move on to simplifying the grouped like terms. And when I say simplify, I mean, again, reducing those like terms into simplest form, which is what I've just shown you guys in that numerical example. So moving on, I'll show you guys a few examples on how to apply these steps here to algebraic expressions. Firstly, simplify 2x plus 1 plus 4x minus y. Okay, where we start, we follow those 3 steps. So first, we identify the like terms. And identifying them, we have an x, we have x's highlighted in red, and we've got a y, a numerical like term, and a negative y. I highlighted the x's in red so that it makes it easier for us to pick out how often x occurs, and in doing that allows us to group the variables later on. In terms of the y minus y and the plus 1, I didn't highlight those because they're both separate variables, separate like terms, so can't really do much of those for the meantime. So we've pretty much done that. In doing this step here, we've come to conclude that there's an x, there's a y, and there's a number 1. So, moving on, we go on to the next step, and we group the like terms. So again, when I say group, we pretty much bring together the like terms that are similar or the same. So in this case, we've got our x's, which are the same, so 2x and 4x. The other terms, they're not the same, so we have to leave them where they are, and they can't be interrelated with one another because they're both separate. Minus y is another like term, so it can't be separate to x. 1 is a numerical like term, so that can't be the same as y or x. So we just leave them the way they are, we don't do anything with them for the meantime. Moving on, we go on to our third step. We simplify the like terms. So looking at our groups, we look at the x's. 4x plus 2x gives 6x, minus y gives minus y. We don't add or subtract anything because we only have one variable here, so we just leave it the way it is. 1, we just leave it as 1 because we don't add or subtract anything, and this leaves us out to our solution 6x minus y plus 1. Okay, moving on to a harder example. Simplify minus y plus 2x minus 1 minus 4y plus 8z squared minus y plus 9x. Again, we apply the 3 steps to solve this more complicated equation, but don't be alarmed. Applying these 3 steps will allow us to simplify it very easily, so trust me on this. So, first step, we identify like terms, just like we did in the first expression. So looking at our like terms here, we notice that we've got a negative y, negative 4y, and negative y. Since our y's are all negative, I like to leave the negative part of the like term. It just makes it easier to solve and doesn't get more messy. We've got, in terms of our x's, we've got 2x, 9x, and we've got 2 other terms, 8z squared and minus 1. So we've identified those, and we have minus y, minus 4y, minus y, 2x, plus 9x, plus 8z squared, minus 1. So we've done that step. What I like to do here is put brackets around the negative y-like terms. As you can see, I like to put brackets there. It just makes it a bit more nicer to look at, because when you have negatives around here, it looks a bit confusing. So what I tend to do is take the bracket inside the like term and put a plus on the outside, like that. And effectively, that's the same as doing this, writing minus 1 minus 2 as minus 1 plus minus 2. So it's always good to put a plus in there. Just makes things a bit easier. Moving on, we group the like terms. So again, we need to group our y's, our x's, and our other variables. In doing that, we get minus y plus minus 4y plus minus y. And I like to put those in another set of brackets there. That way it makes our expression more nicer to look at, because there's a lot going on here. And our x's, we've got 2x plus 9x. Again, I like to put those in brackets. It's always get into the habit of putting brackets around your expressions when they get bigger and bigger. That way it gets easier to solve. The other variables here, we can't really relate those to these ones here, so we can just leave them the way they are. So moving on, we've pretty much grouped our like terms, so we can move on to the next step and simplify them. We simplify like terms, and in doing that, we'll look at we simplify our y's first, then our x's, and whatever's remaining. So our y's, adding up our y's, we've got minus y plus minus 4y is minus 5y, plus minus y is minus 6y. Our x's, 2x plus 9x is 11x, and with our remaining like terms here, we can just leave them the way they are there. So at this point, we can't really simplify that any further. In doing that, our final solution is then minus 6y plus 11x plus 8z squared minus 1 as our answer. And there you have it. Simplifying algebraic expressions using 3 steps. First, we identify the like terms, and by that you see what's in the expression here. Right? Try and get an idea of how many terms there are, how often they occur. Next, we group the like terms. So we pretty much bring everything together into separate brackets, like I put into brackets here, and then we simplify those like terms. So we simplify the y's, we simplify the x's, and we simplify the numbers, or whatever groups we have available, and that's it. Using those 3 steps, you can pretty much solve any expression even bigger than this. If you've got any questions or anything, just feel free to send me a message in my YouTube inbox or comment. Thank you for watching.